Hello, wonderful people. Nice to see you again. So, I didn't do the right title screen. This is Insulators and Conductors. It is chapter 32, section 4. This is a short and easy day. So, what are insulators? Insulators are materials that do not allow heat to move easily through them. That's what we think of in the everyday experience of insulation. You put on a sweater to hold the heat in. Uh, what else is an example of insulation here? The thermos that keeps the coffee inside hot or the ice water cold. Is that a baby polar bear there? At first I thought it was a dog, but I think that's a baby polar bear. And if you live in the polar Arctic, then you definitely need good fur on you. And if you're not a polar bear with a good coat of fur, then putting on a nice heavy sweater like that will do the job. Or those rams, are those Himalayans? I don't know. But look at that thick coat. That is definitely going to keep them warm. What the insulators help do? They help keep your coffee hot. They hold the heat in. And when you're wearing the coat outside, they keep the cold out. Oh, and that's just another way of saying they keep the heat in, right? What are conductors? Conductors are materials that allow heat to move easily through them. So, if you want to fry an egg, can you just crack an egg over the fire and let the egg fall down into the fire? Well, I guess you could fry the egg on the ash, but I don't want ash in my egg. So we have a cooking pan. And that lets the heat from the fire, or the electric coil, into the pan, nice and quick and easy, and then it cooks the egg. I know this isn't rocket science here, but are you with me? Great. Examples of conductors: metals, 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 metals. Glass, is that a conductor? No, that's a good insulator. That's why we use it to keep our drinks cold. And for windows, you want to see through a window, but there are other materials that you can see through. We use glass because it does a pretty good job of keeping the heat in. Paper is a good insulator. Who's hungry? Ooh, suddenly I am hungry. That looks really good. To eat, you must decide which material I need to cook with. Do I need to cook with an insulator or a conductor? The answer is, I like that graphic. Conductor! Yay, conductors! Okay. So moving on to part 2. Building the, oh man, that is a good animation. I wish I could claim credit for that. Conductor, insulator, electricity, resistor, thermal energy. We're going to get into all that. Do we need to do this? No, we do not. So, conductor is anything that allows heat or thermal energy or electricity to move through it. Oh, I'm sorry. Let me just read what's written here. Anything that allows heat or thermal energy or electricity to move through it easily is a conductor. Anything that slows the movement of heat, thermal energy, or electricity is an insulator. So, conductors and insulators also apply to moving electricity. In our ordinary life, we only ever think of insulation and such as in terms of heat, but here in the electricity part, we're going to be thinking about electricity. So, match the label. A penny is a good conductor. Styrofoam is a good insulator. A plastic fork is also a good insulator, and a metal spoon is a good conductor. Are we good there? Flow of heat. Heat is the transfer of thermal energy between objects of different temperatures. Heat travels from a warm object to a cool object. I know it seems obvious, but you'd be surprised how sometimes you get confused. And no, heat does not flow cold to hot. And also, there's no such thing as cold that's flowing from cold to hot. Cold is just the absence of heat. So if you have a lot of heat and a little heat, the heat's going to go from where it has a lot of heat to where it has a little heat. Capiche? Great. And here we go with some notes. You should write this down in your notebook. Oh, speaking of notebook, I haven't posted the notes for the last few days. Sorry about that. I will get that done over the weekend. So, um, well, this is going to be answers in your homework. So if you have to come back to it, here it is. Conductors, materials that through which electric current flows easily. Please note, this definition is only talking about electricity, electric current. Insulators, materials through which electric current cannot move. Examples, metal, water, ordinary water, like that comes out of your tap, is a very good conductor. Examples of insulator, styrofoam, rubber, plastic, paper. Yep, all good stuff. Wood. Oh, then we're going to switch over to, what was I going to do? There, conductors and insulators. This is a little bit more sciencey. It's still pretty easy stuff. When it comes to the flow of electric current, all materials fall into three categories. Insulators, conductors, we just talked a bunch about that, and then also resistors. Insulator, any material that does not allow electric current to pass through it, just like the definition we covered. So the outside of a wire has insulation on it because you want the plastic. It's also rubber. If you look up, like when I look outside my window here, I'm looking at a telephone pole, and on top of it is one of those big cans that's a transformer. And if you look closely at this transformer, you can see there's an insulator on the top of the transformer and also over on the wire. And if you look real close, you can see how the wire is being held by these glass insulators. Now, the one that I'm looking at, it's not glass. It's not see-through like that. It's kind of a flat gray color. So that's just a ceramic piece. In fact, I will put pictures of that up for the next time I do this. Cloth, wood. That's why telephone poles are made out of wood. They don't use metal telephone poles because if something goes wrong, the electricity goes through the metal pole and right into the ground and could hurt people. So insulators like plastic and rubber are used as covering for electric wires. You want to keep the electricity on the inside so you can touch a wire and not get shocked by it. Makes sense. Conductor, any material that allows electric current to pass through it. Copper, aluminum, steel, gold, yeah, any metal. Resistor. Okay, here's where things get a little different. A material or a device that allows some current to pass, but converts some of that current into another form of energy. So, this is where we take electricity and we make it useful for us to do something else. The oldest use of electricity is a good old-fashioned light bulb. You can also have electric cars, electric buses over there. That's an electric rail car. There's the electricity, there's the wire, and that brushes up against the wire to get the electricity into the car. Fans, pencil sharpeners, yeah, all kinds of things. Electric motors make motion from electricity. Oh, something even more basic, heat energy. On cold winter nights, sometimes I'll put the electric heater in the bedroom just because it's still a little too cold. Toasters, ovens. Oh, and who doesn't like to listen to music or the neighbors talk to you? Yeah, you can take electricity and turn it into sound. Yeah, we're going to cover this real quick. So in order for electricity to flow through this light bulb, pictured here, you have to have a path for current flow. So the electrons come out of there, through the wire, then into the light bulb, through the light, and then back out, and back into the source. If you don't have a complete path, then you don't have a circuit. An electric circuit might be open or closed. There, the light is on, but if you break it, the light is off. And there's a switch on the wall that we use to break circuits to turn lights on and off. Okay, good enough.